Hello, my dear students. Welcome back to our AI journey. I'm your teacher and friend, Pradeep. It feels so good to see you again. In the last video, we saw that AI is like a big house with many rooms, and inside each door, there are many special things happening. And today we are going to explore where in this house something called deep learning lives. Yes, I know we have already talked about it in previous chapters, and I am so happy that you remember. But now it's time to go even deeper into the room where the real magic happens. Get ready to meet neural networks, the machine's brain that learns just like us. Shall we begin? Okay. Deep learning versus machine learning. Students, do you know a lot of times people think deep learning and machine learning are the same things? This is not fully right and also not fully wrong. Are you confused? Don't worry, let us understand the difference clearly. Remember our AI house from chapter 5? It's huge. It has many rooms. One room is for robotics, where robots are made. One room is for language, with machines that talk. There are other rooms too, like computer vision. And there is a special room called machine learning. That is where machines learn from data. Now, imagine, inside this machine learning room, there are many wooden shelves. Each shelf is a different way of learning. One of these shelves is called deep learning. Students, do you see? Deep learning is not a different room. It lives inside the machine learning room. So we can say that deep learning is a type of machine learning. But remember, apart from deep learning, machine learning has other shelves too, like algorithms, statistics, and other types of learning. In short, AI is a big box. Inside it, there is a smaller box called machine learning. And inside that box, there is an even smaller box called deep learning. Now let us understand what makes deep learning different and special. What is deep learning? We already know that scientists are trying to make machines that are able to think, learn, and make decisions like humans. One day, a very interesting thought came to them. Scientists thought, if we want machines to think like humans, why not take inspiration from the best brain we know? The human brain itself. That's when the idea of deep learning was born. Students, our brain is made of billions of tiny cells. These tiny cells are called neurons. I know neuron is a big word, but don't worry, we will understand it slowly. What is a neuron? A neuron is a special cell in our brain. It is like a tiny messenger that helps in sending messages from our body to brain and from brain to the body. It is with the help of this tiny cell that our brain understands everything. You must be wondering, is one neuron enough for our brain to do complex tasks? That is a great question. And the answer is no. One neuron alone is not powerful. Our brain has billions of neurons. These neurons join together to form a network. Just like many plants and trees together form a forest, this network of neurons is called a neural network. A neural network is like a big team where all neurons share messages and work together. Because of this team, our brain can think, remember things, and tell our body to walk, talk, and write. That's how you can see, hear, smell, and even solve maths. Scientists use this idea to make computers learn like our brain. They created artificial neural network made up of thousands of artificial neurons to help AI think like humans. Isn't it wonderful? First, one artificial neuron takes an input. For example, information from a picture. This means the computer does not see the picture like our eyes. For the computer, the picture is made of many tiny parts. It looks at these small parts and uses them to understand what is in the picture. The neuron then does a small calculation with this information. After that, it sends the result to the next artificial neuron. Step by step, this message goes through thousands of artificial neurons. In the end, the machine completes the task we asked it to do. So students, this is deep learning, where AI learns with the help of an artificial neural network. It is able to do many things like recognizing our face and unlock our phone, and helping us avoid traffic by telling us the best route on Google Maps. Isn't it wonderful? Remember the big difference. Our neurons are natural. They are living parts inside our brain. But artificial neurons are not living. They are made by humans inside a computer to work like our neurons. But they are non-living. How deep learning works? The question that started it all. Now, let's first ask an interesting question. Why is it called deep learning? For this, let us go back to chapter 2. In chapter 2, we got a brief introduction to deep learning. Do you remember? Don't worry. Let's revise it together. Think of how you find your mother in a market. Do you only look for her clothes? No. You notice her height, her hair, her voice, and even the way she walks. By checking all these details together, you say, "Ah, there is my mother." Deep learning is just like that. It doesn't depend on one thing. It checks many things at the same time before giving an answer. It's a special kind of machine that doesn't just look at one thing, it looks at lots and lots of things, one by one. It's like solving a puzzle by checking every single piece before saying, yes, this fits. Remember, we talked about face unlock feature on our phones? When you unlock your phone with your face, it doesn't just look at your nose or your eyes. It studies hundreds of small details like the shape of your face, how far apart your eyes are, or even your smile. This way, deep learning helps AI do even complex tasks with high accuracy. With more layers, the machines could learn better and understand more complex problems. For example, when AI looks at a picture of a cat, the information goes through many layers. The first layer looks at simple lines. The second layer joins the lines to make shapes. The third layer sees features like eyes and ears. The last layer puts the answer together and says, "This is a cat." The number of layers makes the network deep. More layers means deeper network, which means smarter machines. That is why it is called deep learning. Deep means many layers. Isn't it exciting, students? A brain like ours inside a machine? Let us learn more about these layers. We will start with the input layer. The first layer in the network is called the input layer. This is the starting point where input goes in. Any data, command, or question that we give to a machine is called input. The input layer takes our command or input and makes it ready for next layers. If we give a photo of a cat, the input layer looks at the many small parts of the photo and gets the information ready for next layers. This brings us to the hidden layers. These are the middle layers which take care of the middle steps. It's like a busy factory. Here many small helpers, that is artificial neurons, work together. First they get information from the input layer. Then they look for very simple things like lines and curves. Next, they join those lines into shapes, circles, triangles, ovals. Then they join shapes into features, eyes, ears, hair. Step by step, the network reaches the answer. But students, now let me tell you the most interesting part about deep learning. Are you paying attention? Very good. In deep learning, when middle layers reach an answer for the first time, it could be right or it could be wrong. For example, after looking at the cat's image, the machine may say, "This is a dog." The network itself first checks if the answer is correct. Just like we sometimes check our answers during a test to see if we made any silly mistakes. If the network finds the answer is not correct, then it sends a message to all the layers behind, saying, "Wait, we made a mistake. We need to fix this." Then all the layers and neurons check and adjust their work. Then they again send a message forward, layer by layer. Finally, the network gets a different answer. This is how the machine tries to give us the best answer. Students, do you see how the middle layers work really hard? You must be wondering, why are these middle layers called hidden layers? That is very smart question. You students are really smart. These layers are named hidden layers because these are hidden inside the brain of AI. We cannot see what is happening inside them directly. We only see the input that goes in and the result that comes out. The middle work, how the network changes lines into shapes and shapes into parts, remains hidden from our eyes. Just like we cannot see inside our brain, but we still learn, make decisions, and solve problems. The last layer is the output layer. This layer gives the output. An output is a response that a machine gives to us. It could be a solution, or a result, or an answer, or even a question to understand our input better. The middle layers pass on the answer to the output layer. The output layer prepares it to share with us. So it is the output layer that gives us the final answer. For example, it would say, "This is a cat." This is how deep learning works with the help of neural network. It is truly fascinating. Now, let us take a real life example to see these deep learning layers at work. Students, many of you must have used Google Translate sometime. Maybe you typed a sentence in Hindi and it showed you the English meaning in just 1 second. Have you ever thought about how it does this? How can a computer know which word means what? Today, we will learn and understand this process. Suppose you write this sentence in Google Translate. कल मैं बाजार गया था. The first layer of the deep learning network takes it as an input. It starts working immediately. This layer's job is simple. It breaks the sentence into smaller parts so the computer can look at them one by one. It separates the word कल मैं बाजार गया था. The second layer now starts working. Its job is to look at each word and find its meaning. Kal can mean yesterday or tomorrow. Main means I. Bazaar means market. Gaya tha means went. When these meanings are put together, the computer may first think, yesterday, tomorrow I market went. But this does not sound right in English grammar. Right? Now the third layer comes in. It checks the grammar and changes the word order. It adds words if needed. It might make it, I went to the market yesterday or tomorrow. But there is still a problem. It still has to choose between yesterday and tomorrow. This is where the fourth layer does its job. It acts like a detective. It looks at the whole sentence and notices that the verb gaya tha is in past tense. This means the action has already happened. So it decides kal must mean yesterday. Finally, the last layer puts everything together and gives the correct answer. I went to the market yesterday. If you write another sentence in Google Translate in Hindi, कल मैं बाजार जाऊंगा, it translates it quickly too. Let's understand how it works with the help of a team of 5 friends. Each friend has one small job. First friend, Ravi, cuts the sentence into small parts so it can understand easily. Second friend, Meena, looks at each word in a dictionary and finds its meaning. When she sees kal, she pauses and says, this can mean yesterday or tomorrow. Third friend, Uma, checks the grammar, arranges the English words in the right order and also add words if necessary so that the sentence sounds correct. She writes, I will go to the market yesterday or tomorrow. Fourth friend, Ganesh. Ganesh is like a detective. He looks at the whole sentence carefully. He says, if the verb shows past tense, then kal means yesterday. Because the verb shows future tense, kal means tomorrow. Fifth friend. Finally, Rahul joins everything together and speaks the correct answer in English. This is how the layers in deep learning work. Each layer is like one friend. Each friend does a small job. And in the end, they work together to give the right answer. So students, do you see how helpful deep learning is? If we only gave the computer a dictionary for translation, it would get confused with words like kal. It would not know whether to choose yesterday or tomorrow. But with deep learning, the machine doesn't just look at single word. It looks at the whole sentence, the grammar, the tense, and the meaning. That is why it can solve confusing problems that older, simpler AIs could not. That's the magic of deep learning and neural networks. Deep learning versus machine learning. Students, we already know that deep learning is a part of machine learning. Now, let us understand some of these differences. Machine learning. Machine learning is used for simpler problems. It can learn with less amount of data, but it needs organized data so that information is easy to understand. It needs human help to learn. For example, if a machine is being taught to recognize a banana, in machine learning, it can learn from seeing just a few pictures. But the information or data needs to be neatly organized into a table. And humans have to tell it to look at the color, size, and shape. Using these directions, machine learns step by step. So students, remember, in machine learning, we guide the machine and it learns with our help. Deep learning is used for bigger, more difficult problems. It can handle a lot of data. It does not need organized data. In deep learning, the computer learns by itself. For example, in deep learning, the machine can be given lots of data and it will look at it and learn by itself. We do not need to tell it to look at the shape, size, or color. It will do it on its own, layer by layer, with the help of artificial neural network. So students, in short, machine learning is used for simpler tasks, uses less data, needs organized data, and learns with our help. And deep learning is used for bigger, difficult tasks, can handle lots of data, can even work with unorganized data, and learns by itself. Deep learning around us. Google Translate. We have already seen how Google Translate uses deep learning to translate a sentence from Hindi to English. With deep learning, the machine doesn't just look at single words. It looks at the whole sentence, the grammar, the tense, and the meaning. YouTube recommendations. Students, we already know YouTube's AI watches what we like and suggests more videos of the same kind. That is deep learning. Self-driving cars. Self-driving cars use deep learning and artificial neural networks to recognize signals, people, and roads, improving with every drive. Weather warning system. In India, AI systems are used to keep a watch on the weather and give early warning for cyclones and floods, saving thousands of lives. Google Voice Search. Students, have you ever gone on Google and pressed this symbol? This is the symbol for microphone or mic. If you press this, Google will be ready to listen to your voice and you can ask Google anything with your voice. You do not need to write it in the search bar. Google's AI will listen to your voice and understand it and convert it to text and show results as of your search. And how does the AI do it? With the help of layers of artificial neural network. So students, deep learning is already around us. It is not just in science labs. It is already part of our daily life, and its future is even more exciting. In farming, smart drones can watch fields from the sky. They can spot sick plants, count crops, or suggest the best time to water. In space, it can help robots explore planets, study stars, and maybe even find life far away. Challenges of deep learning. Students, deep learning is amazing, but it also has some challenges. Let us understand them one by one. Deep learning learns by finding patterns in data. To learn well, it needs lots and lots of data. If there is not enough data, then machine can make silly mistakes. Needs powerful machines. Deep learning is heavy work for computers. It needs powerful machines to train and run properly. That is why big companies like Google, Amazon, and Microsoft train most of the huge deep learning models. Sometimes deep learning gives the right answer, but we do not know how it reached that answer. Inside the hidden layers, a lot of complex steps happen that are hard to see. It's like a magician's box. Data goes in, answer comes out. But what happens inside is a mystery. This can be a problem in serious situations, like when AI decides about bank loans or gives medical test results. Can copy biases from data. Deep learning learns only from the data we give it. If the data is unfair or incorrect, the results will also be unfair and incorrect. For example, if most training photos are of black dogs, the AI might wrongly assume that all dogs are black. So students, remember, even the smartest machines learn from us. If we guide it well, it will help us well. Now, before we end today's lesson, let us quickly revise what we learned. Today, we learned that deep learning is a part of machine learning. AI is the big house. Inside it, there is a room called machine learning. And inside that room, there is deep learning. We also saw that deep learning is inspired by our brain. Our brain has billions of tiny cells called neurons. When these neurons work together, they form a neural network. This network helps us see, hear, and think. Scientists got inspired from this idea and made artificial neural network, where neurons are connected to help a machine do many things. Then we also saw how deep learning works. In deep learning, artificial neural networks pass data through layers. For example, if a machine is given an image of a cat, each layer does one small job. One layer sees lines, another sees shapes, and another finds parts like eyes or ears. The last layer puts it all together and says, "This is a cat." That is why it is called deep learning, because it has many deep layers. We also learned about the names and functioning of layers. The input layer is where data, command, or a question goes in. The hidden layers are like a busy factory, and the output layer is where the final answer comes out for us to read. We also learned that hidden layers are hidden inside the network and we cannot see them, just like we cannot see our own brain. Then we saw how the layers are at work in Google Translate. The layers work like a team of friends. One cuts the sentence, one finds the meanings, one fixes the grammar, one looks at the whole sentence carefully, and one gives the final answer. With deep learning, the machine doesn't just look at single word, it looks at the whole sentence, the grammar, the tense, and the meaning. That is why it can solve bigger problems that older, simpler AIs could not solve. Then we further explored the difference between machine learning and deep learning. Machine learning is used for simpler tasks, uses less data, needs organized data, and learns with our help. And deep learning is used for bigger, difficult tasks, can handle lots of data, can even work with unorganized data, and learns by itself. We also saw some interesting examples of deep learning that are around us, like Google Translate on our phones and computers, or YouTube video recommendations. Self-driving cars, weather warning systems used by governments, and Google Voice Search that we use every day. Finally, we saw the challenges of deep learning. It needs lot of data. It needs powerful machines. It is sometimes hard to understand its decisions because we cannot directly see the hidden layers. And lastly, AI can copy biases from data. If the data is unfair, the answers will also be unfair. Students, deep learning is powerful and useful, and in the future it will do even more amazing things. I am so proud of you for listening patiently. I will see you in the next video. Until then, ask questions, stay curious, and I will see you very soon. Goodbye.